Hello everyone. I hope you are doing extremely well. So today I'm back with one more installment of our system design video, and here we are going to see how we can design the payment systems of e-commerce giants like Amazon. So now when we are talking about the payment service or the payment service or the payment system of e-commerce, so we are not really talking about the digital payment systems. Okay. So when I say it is what it is not is uh, it is not really the UPI or any kind of wallet like Paytm. We are not considering that. What rather we are going to see is how within Amazon, suppose you are registering yourself as a seller. Okay, suppose one user, he is a seller, and then another person who is their buyer. So and in between them, of course Amazon is working as a broker sort of a thing. So when buyer buys anything, he puts on some money, right? So how that money goes to Amazon and how that money goes to seller, and how exactly the whole system integrity is being maintained, that is something that we are going to discuss today. Okay, so it is not really about how any kind of UPI or the digital wallet or any other digital payment flow will happen, rather how this whole seller buyer and in between Amazon being the broker, whole conjunction is happening. We are going to explore that one. And two is, if you are looking for something like a digital payment system, my next video will be digital payment. So if you are looking this video maybe like somewhere around May, probably it is already there. So now let's discuss a little bit more about what exactly our requirements are, and we will try to figure all the detail out of our system from the requirement only. Okay, so let's get some clarity around the requirement gathering part. Requirement gathering of the functional and NFRs, like the non-functional requirements. So this is something that we are going to see now. Okay, so now let's see around this. So there is a certain seller. Okay, so there is a certain seller. So this seller have suppose product A. Okay, in between Amazon is there. So what he does is he does a listing in Amazon or Flipkart. Okay, so here listing of his product in Amazon. Now again, the most important part is here the buyer, because from the buyer the main commoditized money is coming. So what the buyer is going to do is buyer is going to buy that listed product. Okay, so buyer is buying product A. Now, so for that definitely the buyer is going to pay money, right? So buyer is going to make some payment. Now who is going to receive this payment? So at first Amazon is going to receive this payment. Suppose Amazon is taking $3 for this. Okay. Out of this $1 it will keep, and what it will do is there will be like $2 it will give it to seller. So if the buyer is paying for buying product with $3, or let me write in this way, $3, Amazon is keeping $1 and seller is getting $2. Okay, so this is on a very high level what the flow is, and of course there is a lot of other thing happens. For example, Amazon can hold the money for some time. There will be cases like refund. What happens when some order is placed but payment failure happens? or a payment delay happens. So there are multitude of scenarios will be there, which we will try to cover few of them in our whole discussion. But on a very like a 10,000 feet level, this is exactly what is happening there. So now let's talk about little bit in terms of properties and the databases, and like what would be the few of the properties of our system. Okay, so suppose there is a buy now button. Okay, so suppose there is a buy button, and there is a certain user. What this user is going to do is, user is going to press the buy button, and what it will have is, the moment it presses the buy button, it is going to have some kind of a checkout ID. So I'm checking out my card, suppose. So there will be a checkout ID, and there will be like buyer info, there will be product info, or rather the product info I can place like inside orders. So there can be multiple orders in a single buy. For example, user in the same like in the same order, what they can do is, in the same checkout, they can do is, they can place one order to buy a refrigerator from one manufacturer, and they can also buy some utensils from maybe some local manufacturer. Okay, so all this things will be getting created when we buy. So after we buy, what will happen is, we are going to create payment order. We are going to create a payment order. So this payment order is definitely one of the most important point of interest for us. So it can be like payment order ID, and so we will again come into the actual database and the other properties in some other way. But this, why this payment order ID is important is, just think that you are using to something like Paytm or GPay, okay, to buy these things. So what will happen is, this payment order ID will actually keep a track of will keep a track of payment status at my third party. This third party is anyway being called PSP, or payment service provider, but we will definitely come into those things later. So I'm not going into the detail, but just understand this thing. This payment order ID is one of the key information for us. Okay, so this payment order ID is basically e-commerce payment order ID, and it will have some kind of a relation with the Paytm or GPay. Okay, so like payment order ID on Amazon side, and payment order ID or the transaction ID on the GPay side. So it will be kind of a relational thing. So now, as we already introduced this thing, MSP, so let's talk a little bit around that. Okay, so this is the most important part of, sorry, uh, not MSP, it is PSP. So PSP is basically payment service provider. Okay, so this payment service provider is the one of the most important, or I would say is kind of a heart of this payment. And it can have its own payment service, like any e-commerce can have its own payment service provider. For example, Amazon might have Amazon Pay. Also alongside that, it has various cards, various debit cards, and also there are like payment platforms like Razorpay, Stripe, or PayPal. Everything it supports, right? So all these things, for example, Razorpay, okay, PayPal. These things are the examples of our PSP, or the payment service provider. All right. Now, uh, suppose there is a payment service provider is there. So it will map this payment order ID, and it will also send you one confirmation whether our order is being successful or not. And then what it will do is this will process the transaction, and it is the responsibility of the PSP that suppose buyer, I will just try to box this thing out. Buyer buys something. So what buyer will do is buyer will talk to PSP. Okay. So buyer will talk to PSP, and this PSP, payment service provider, then on success, if the transaction is successful, on success what it will do is it will send that money to the bank account of e-commerce. So suppose Amazon has a certain bank account for their money, and buyer buys it for 2000 INR. Okay. On success what it will do is this is the Amazon this is the Amazon bank, and what Amazon bank will do is it will at first hold 200 INR. Okay. Then what it will do is there will be this seller bank account also. Okay. So alongside this there will be this seller bank account. So suppose Amazon has like a 10% cut sort of a thing. So like there will be some kind of a ledgering process goes on. So some kind of a ledgering happens, and what it will do is it will send that 1800 by putting that 10% into by putting that 10% into account. So it will keep like 200 INR, and this 1800 INR, what it will do is this 1800 INR it will transfer into the seller account. And also there are a lot of process like ledgering and the reconciliation happens. We will go into the detail of the technical details of all of those things later. But anyway, this is again like I'm just trying to incrementally build our understanding. As you see, like this is the seller buyer relation, and this is how when PSP is being introduced, and one more concept of ledgering that is being introduced, money is being transferred from that Amazon's bank account or the holder bank account by cutting the platform fee to the seller account. Okay. And this is ledgering, or there is one more part, it is being called as a payout. So because seller deserve the money of that after cutting that 10%, so um, this payout is being done to the seller. Okay. Now just see um, how beautiful this design is. Like as we were talking about the ledgering, if I have to just think about in a single database how this ledgering will happen and how I can maintain the integrity of the system. Okay. So let's take an example of this one. Okay. So you see this ledger entry is something that we are going to have a table. Okay. So this table have entry ID. Entry is nothing but any incremental ID you can think. So there is a debit account and there is a credit account. So at first you see the buyer. Okay. So in the step one, what will happen? In the step one, so if I can connect with this one, here what is happening is buyer is being connected. Okay. So buyer is sending the money through PSP to the custodial account. So custodial account is basically the Amazon account. Okay. So here from custodial account, what is happening is like in this stage, that you see, this stage, what is happening is this stage actually connects to this second query. Okay. This actually connects to this second query. And what about this third query? what third query is telling is this 200 uh, INR, instead of putting it here, we are going to have another revenue account. Okay, so instead of this bank account, what we are going to have is we are going to have one more revenue account here. That $200 is going to be um, placed. Okay, so a little change from what we were doing. To simplify, initially we told that it will be in the same bank account, but now as we see in the ledger entries, we are able to identify that it is basically another revenue account where I'm going to transfer my money into. Now you see this ledger, how easy it is to maintain. I just have to, like, whether this is a valid or everything went perfectly or not. To understand that, I just have to add this part, this $90, and with this $10, and equal it with whatever the buyer have sent it to the custodial account. If it matches, then I know that all my transactions and every flow regarding payment has gone correctly. So that is why the ledger entries and the PSPs, the integration of PSPs and other stuffs are very, very important here. So now, what are the key components in action? So what are the key components in action? If I have to just list all these things, so there is payment service, there is PSP. Payment service is something that we are designing, and then there is like custodial account, revenue account, and ledger. All these concepts are very, very important. If anything is not clear to you, I strongly suggest that you just revisit this whatever we have discussed one more time. It will be probably very clear. If not, just Google search any of this thing. For example, a ledger is not clear to you, you just Google search, it will be very much clear, like what exactly ledgers are and what it is being used. But again, on a very high level, ledgers are the one, those entries, if we do mathematical calculation on top of it, we will be sure that okay, the whole flow is exactly correct. And as I have explained to you, like here, doing this 90 plus 10, we we can easily derive that okay, this much the buyer have actually transferred as part of the transaction of his buying. So now let's have a let's do a little bit more deep dive into our into our main payment service that goes. Okay, so now that we have this buyer and we have this PSP in place, so uh, after PSP, now if I just take these two components like buyer, okay, so before going into the on success, there is always something called risk check service is being run. Okay, so risk check service, it can it can be placed in multiple places. Generally, like it can be placed here also to understand whether it is a malicious buyer or not. Like for example, there can be a buyer who just keep on ordering and like keep on returning stuff. So there a risk check service is important before even coming into PSP. And PSP, considering, has its own platform to do all kind of a risk check. So this is like platform risk check, we can say, and this is PSP risk check. So this is one of the very important part. Okay. So here, so now probably you understand, with Ledger and all, we also introduced one more thing called risk check service. Okay. So what exactly is happen over there is like the user click on the buy now, it sends a payment event, and then that payment event is being the payment event has to go through things like various risk check, and after that whether the payment is successful or not, that is returned, and then the e-commerce platform system registered it as a order, and like mark it as a payment successful, it confirm the order and initiates all the delivery procedures and stuff. Okay. So now the next stuff is, now let's concentrate upon that what will be our API endpoints and what will be our data model. So as I am writing this payment service, right? So this, for this particular payment service that I will be writing, what will be the API that the buyer will call? The PSP will definitely be a different endpoint because it's a third party, the payment service provider. But for my platform, what is the APIs that I am going to design? Let's concentrate upon that, and we will also try to touch upon the data models. And based on those understanding, what we will do is we will try to uh, extrapolate it into the bigger scheme of things, like when the reconciliation service and the ledgering and everything will come together, and we will see how the whole thing will work in a distributed manner. Okay. So the first and the foremost API that we are going to need is for performing the payment. So it can be like as simple as like when the user presses that complete payment button after entering all the information, then there will be something like a slash uh, payment post API. Okay. So this is going to be a post API, and this is going to be something like slash payment. And what it is going to have is, let's I will just copy paste it just to save some time. So here you see what we have is, we are going to have all the buyer data, we are going to have a checkout ID. Generally if you have bought anything, you might have noticed like you have to check out and then that order uh, goes on, and even if you press a buy now, there is a checkout ID that is being generated behind the scene. And suppose I am paying it via card, so in that case it will be a card token. And in case I am buying it by some third party, like I'm using the any other PSPs like Razorpay or UPI, then this type will be definitely changing, and this token parameters will be something else. And this have all the payment order details. And you see this payment orders, one of the important part is like this payment orders is a array. So what does it mean? Why a array? Because within a same, or like within a same checkout, there can be multiple orders to different sellers. So to segregate that seller, we are going to have this different uh, mm, uh, amount. So suppose now the first checkout is like total $200 is my total checkout and the order amount. The first seller 456 is for $100, as you see over here. The next seller like 457 will be getting the next $100. So this is how the multiple order to the different sellers will be placed. Okay. And once it is successful, what will happen is, we are going to have a response like this. So it will tell that okay, the transaction, this is the transaction ID, and status will be at first definitely processing. And how we come to the complete or the pending status or the failed status, we will try to explore it further. But this is something that we are going to have our response. And here you see one of the Web API design convention is something called HATOS. So HATOS is something like when you are giving the next URL from where you will get your actual data. So as you see this webhook acknowledgement, so this webhook I will be listening to, and this webhook will give me the data that whether this status is processing or not. So what I will do is, once I get this response from my side, I will keep on calling this webhook, and this webhook eventually will give me whether it is a pending status or whether it is a failed status or a success status. Okay, so this comes to the most important API for us, and then there can be something like a simple get with a specific payment ID. I'm not going into all those details like get specific payment details. And here also, like we might get, for example, whether my payment is successful or not, those kind of information it will show it to the user if he wants to see a certain payment processing status. This will help user in that way. So this is on very broad level whatever the necessary APIs we are going to have, and like failure handling, many circular or the webhook handling things, I'm not going into the details. So this is the core of our application right now, like the retry, refund, all these things we can extend as we grow the system. But right now we are just trying to get our minimum viable product or MVP done, so we are restricting ourselves here. But anyway, the refund or retry, all these things can be there. Okay, now let's talk about our data model. Okay, our data models and database. So at first, let's discuss what is the type of database that we are going to use. Okay, so question is the type of DB. So whether it is going to be a NoSQL or a SQL or a RDBMS sort of a thing. Now, if you see, this is a highly relational model, and also it requires a lot of consistency related guarantees. For example, when I was talking about that ledger, okay, some time back, you see that there is a certain consistency guarantee we are going to require over here. For example, in case this insert into statement is there and for some reason we do not have the currency, then it's a problem. So there are a lot of integrity and a lot of consistency related guarantees we are going to require. And also if we just talk about the like a read per second or the QPS, okay, or the query per second, and the amount of WPS, that is the write per second, we will see that payment is not very intensive like any operations like a data streaming or click stream sort of a thing. Payment, what it is happening is like probably if I actually have to do the envelope estimation, probably we will see that 100 transaction per seconds, that can be a maximum. And I think that also is going to be a too much if my data is getting sharded properly. Okay, so it is RDBMS is quite okay to handle this kind of transactions. Okay, like 50 transactions or a 50 writes per second, it's completely fine to do, and in line with all the guarantees that we are going to need. So uh, let's just think that we are going to have like the PostgreSQL. Okay, we are going to have PostgreSQL for our Postgres as our database, and the PostgreSQL for our querying. Okay, like PostgreSQL 15. And also I would like to emphasize the fact that if you just go and read how Stripe design its financial system, okay, so not the recent architecture but the early architecture of Stripe, it is completely a PostgreSQL. Later they divided the things into a polyglot architecture, but this is a tried and tested thing, that RDBMS work very well with the financial institution with ACID compliance, and with like proper archiving and backup, it works like a charm over there. Okay, so let's talk about few of the data models. So when I initiate my payment, I need a table for that. Okay, so I definitely have the other things like my orders, my checkouts, and my cards and all. But when I initiate my payments, that is the first time it is going to hit my payment service. So in my payment microservice, so in case you think payment as a microservice, this is the first time I will have my data, and my data will some way look like this. I'm going to copy paste the table schema to again save some time and discuss from here. Okay, so you can see over here this payment event that we have. So payment event going to have our checkout ID and our buyer info, seller info, and all the other details like to whom I have to pay. And using this checkout ID, I can actually refer to my order or the checkout table and try to see what are the what are the actual information related to that particular checkout. Based on that, I can do joining, and I can try to get the information like what is the amount for that particular checkout to be transferred for that particular seller. So this is something that is imperative for our database. Okay, so now there will be, like as we were talking about, how from this payment event we are going to figure out how many orders are related to this particular payment. Okay, and what exactly is happening with this, like um, uh, where to send my data. For that I am going to need another table. Okay, I will just place them side by side for your better understanding. So you see, initially in the payment event, one event is getting generated, and after that event is getting generated, I am going to have my payment order ID. Okay, so this payment order ID is going to have all the necessary details, uh, like all the buyer information, what are the different orders under that particular payment. Okay, what is the checkout ID? So checkout ID will be my foreign key over here. Okay, you see the references, and what is the payment status, whether it is success or failed or executing, all those details will be put into this. And then once this payment status is being succeeded, and I know to whom I am going to pass my I'm going to pass my money into the seller's account. Okay, once I get that information, what I will do is I will have my ledger entry table. Okay, so now from this two table, what are the information I have? I have that whether a payment is completed or not. From here, I will just try to put a pointer over here. From your seller info, I am going to find out to which seller I am going to pass my money into. Okay, and for each seller, I also know the amount correspond to them. Okay, that whether this payment is completed or not. So once that payment is completed, from my debit account or my primary account, which we termed as a custodial account initially. Okay, from this custodial account, what will happen is we are going to send our money to the uh, seller's account. Okay, now this is going to after that my ledger will be updated with all the debit and the credit account. So with this, my whole process will be completed. Like I have my payment event, I have all my payment related orders, and after the order is getting completed, I am going to transfer the money to my seller, and for that I am going to have this uh, ledger entry. And of course there will be lot of other tables for the seller information, for the buyer information, for maintaining some other data. I haven't listed all of them here, but this is on a very high level something it will be. Okay, so now let's try to put all this thing together in a diagram now. Okay, again we are incrementally building one by one. We are incrementally understanding one by one components, and what we are trying to build is we are trying to see how it fits into the greater scheme of things. Okay, so here let's see how all things come together. Okay, so now I have a initiator. Okay, now I have a initiator. Suppose initiator something can be initiator like buy now. Okay, initiator can be something like buy now, and from buy now it will go to our payment service. From buy now it will go to our payment service. And so what this payment service will do is, so it will insert the data to the payment event and the payment order. So here payment event and payment order table will come in place. Okay, and as it have that checkout id as the if you remember here, checkout id is one of the foreign key that we have over here, and there will be of course many other details. I am not going into all the foreign key related details. So it is going to then pass this data to the payment processor. Okay, so payment processor will be probably the code of our heart. Okay, payment order processor, not only payment processor. So what it will do is it will read from the payment order table, and it will read from payment order table and start processing. Okay, so now from here what will happen is it will go to the PSP. Okay, it will go to the PSP and it will request payment. And what PSP will do is PSP will give whatever the result is there. Okay, PSP will give that whether it is a success or a failure sort of a thing. So i'm going to I'm going to need a arrow over here actually. So PSP will give success, failure, status, and based on that what it is going to do is it is going to update the payment order table. Okay, that it is a success or it's a failure. And as the order is now paid, then what will happen is there will be the other systems will be coming here as the order is being placed. Now what this payment service will again do is on success, it is going to again call another external payout processor. So this is a payment processor. Now it will go to the payout processor. So what is the responsibility of payout? The responsibility of payout is taking the money and placing it to the seller account. So now probably it is clear to you that a order is being placed here. So I'm not processing the order flow. I'm not going to show the order flow here. So basically once we get the payment order successful, that one event will generate that will complete the order and the delivery, initiate the delivery related information as well. But the idea of this payment processor is this will make that for this payout processor is this will send the money to the seller account. And also remember there can be also an external gateway. Maybe I am depending upon, like for example the Amazon's custodial account, suppose it is in SBI bank. Okay, so with the SBI or any other external gateway, it is going to send the money to the seller account. And once it sends the seller account, what it is going to do is our ledger table, again one more our database table will come. So table, in our ledger table the whole update will happen that this payment has done and this is what I have cut as per my platform fee, and this is I have passed on to the seller. And this is how again all my tables will come in come in place. So this is a table. Okay, this is a table. All these things are there. Okay, so now again we have kind of a clear idea that how these tables and everything will come there, and try to try to make everything, try to make the whole flow from the ledger. It will make it up. It will uh, complete the whole processing in this manner. Okay, so now let's concentrate upon the payment service provider a little bit. We should talk about this. Why? Because this is again one of the very important external component, and how we handle it, uh, the all the success, failure, and the responses from this will primarily define the validity or the integrity of our system. So what exactly is PSPs, or the payment service providers, are? So if you see anything like Amazon or Shopify or any e-commerce system, you will always see that there is a even there is a debit card or a credit card, like you are saving your details, but again what it will do is it will take you to a certain redirect to a Paytm or Bill Desk, or maybe some other providers. So those providers which gives you that hosted service are being known as the payment service provider, or the PSPs. Okay, so the advantage is, like, your card details go to directly to PSP. You are not owning it. So as a platform, you are not owning it. So the advantage is there are a lot of regulatory there are a lot of regulation process of the finances you are exempted upon, because you are not saving users cards or any other kind of details there. Okay, so uh, it makes the system of course more reliable and the resilient, because I do not have to handle those kind of intricacies or complications. I can just have Stripe or any other any other system to handle that. Okay, and also in the implementation part, one of the very important thing over here is circuit breaker. So circuit breaker with retry. So it might always happen that we are not going to get our response in it within a stipulated time, because there are things like OTP, there are things like network failures. So for a single order there can be instances that I am going to retry, and how I make sure that money doesn't get deducted from the user's account two times or multiple times. I use idempotency key, which we will come in a later point of time. I mean, most of the people, it might be for most of the general engineering audience, what exactly idempotency is, it might be already clear, but still we will cover it. So the idempotency key plus circuit breaker plus retry is something the core of this design is going to be. So circuit breaker means that if I am retrying it again and again after maybe 5 incremental changes for 30 seconds each, or in some other logic, I am going to break it. I am not going to do any infinite retries over there. So with idempotency, retry, and the circuit breaker, we make sure that our payment is kind of a resilience. Okay, uh, so what exactly happens over here is, like, if I have to take this one, the initiator is going to use our platform service, and then it will go to the payment process order, and here comes the PSP. Okay, so here comes the PSP, and what will it will have is, it is going to mark it as payment succeed, or it is going to mark it as a payment failed. And now the very as we were talking about the resiliency of the system, so there can be multiple PSPs in our system. So suppose there is a certain PSP is down, what will going to happen? Will our system, we are not going to make any transactions? So generally in this approach, what happens is any e-commerce site, if you see, it have subscription to multiple payment subs payment service provider. So if anything is failing, the fallback payment service provider will always be used. So there will be a heartbeat system and it will keep on checking, okay, if now the PayPal is failing, I am going to move into the Razorpay, something like that. Okay. And of course there is a like a when we were discussing about this part, like how many times we are going to do this retry, as we already discussed that this thing will be dependent upon this thing is going to dependent upon this retry mechanism is going to dependent upon our uh, with the circuit breaker plus item potency. Okay, so this is something that we are going to have. Okay, so now the rest thing is that the next thing that we are going to have, the related or very important concept similar to this is we are going to have something like reconciliation. Okay, reconciliation. So what exactly a reconciliation is? Okay, so reconciliation is nothing but it is, I will just write it so that it remain on your notes, comparing financial records from different sources to identify discrepancies. Okay, so any banking system like it is th- this used to be a manual process like way back, and now what happens is like your system, because it records all the transactions, so what it does is it actually can make actually can identify any given discrepancies from the different sources. So uh, this ensures that what you think happened financially actually matches what the external party say has happened. Suppose this PSP tells me that I have processed $90, but your system is going to tell your system in some way is telling that the buyer has paid $100. So that is a kind of a discrepancy, and so this to identify this, the reconciliation is a very important process, and this is nothing but a, I mean, if I have to see say like how it is implemented, this is a automated job, and how frequently it runs, it completely depends upon the setting. It can run in a hourly manner or it can run a daily manner, and also like of course the quarterly or the monthly checks happen on top of it. Okay, so PayPal's, for example, PayPal's reconciliation system compares the list of internal record of completed transactions for a given period. It gives you that periodic data, and you can actually compare it with your uh, local records. That is why like my own records of the payment events are very important, and whatever the responses that I am getting in the from here, we also should be logging it to somewhere, but I'm not making this thing part as a payment service. Our discussion will go broader, but for the reconciliation we also should have another table over here, okay, which will have all the details that we get the responses and whichever the amount the PSPs was able to proceed. Uh, so now, if I have to introduce it more formally, what is happening is after the payment service and the after the payment service after the PSP happens. So this thing happens after this. Okay. So I'm going to just draw it just here, but in my flow, after this PSP processing happens, the reconciliation will kick in. So here the reconciliation will kick in, and I'm going to formally like make a uh, make a sequence diagram here. So what reconciliation does is it will start. So it is nothing but a service. Okay, this reconciliation service, it is going to read internal records. Okay, from our database. So from our local database, actually, what it is going to do is it is going to read the internal records. Okay, at first. So this is going to be my step one. And also alongside that, what it is going to do is it is going to fetch, like as a step two, it is going to fetch from the PSPs transaction records. Okay, and then after getting both of these records, it run its own algorithms or own process. So after getting data from this and getting data from this, what it is going to do is it is going to use some AIML classification sort of a thing to understand that whether there has been some kind of a discrepancy or not. And there can be some manual, like simple checks as well. So in current scenarios, to understand all the discrepancies, AI and ML is being heavily used, and there are some self-correcting mechanism as well. So after this classification and detecting discrepancies, upon detecting any discrepancies, it starts some kind of a self-correcting mechanism, self-correcting mechanisms. And if it fails at all, then it also, what it does is it reports to the concerned authorities in some automated process. Report the discrepancies on failure, like if it is unable to do the self correction, so report the discrepancy. And this whole job, you see, it is a automated job. That is the highlight of this thing. So this whole just write internal here to make it more, yeah. So this whole internal PSP transaction record fetching, AIML classification, self correction, everything that you see, this is a complete automated job. Now coming to the next part, and one of the most important part in this payment processing, and I would say one of the most practical scenario. What happens for handling payment delays? Suppose, so payment delay can happen for multitude of reasons. What are the reasons? Suppose a user needs a two-way authentication. Okay, a two-way authentication to place some kind of a place some kind of a order and then get their transaction approved. Like user need to put OTP, OTP, and suppose their bank detects that okay, this is a international transactions. So upon some other bank verification also goes on, and what happens behind the scene is if there is a outlier transaction that is not when I say outlier means which is not happening on your day to day basis, then you might often receive an call from the bank itself that whether they are going to whether they will authorize the payment or not. So what will happen is there is a bank verification they are going to do, and after that they are going to pass the payment. Okay, so this whole process is known as 3ds pending status. Okay, so I will just quickly try to um, draw what happens here. So there is a buyer. Okay, that buyer is calling the my platform API. That platform API is going to call the payment service. So, or I can just tell them that these two things are together. So from payment service, what will happen is it will go to PSP. Okay, payment service, it will go to PSP. Now we are clear till this part. Okay, So when this order status go, what is the payment status in each level? So here the payment status will be pending. Okay, in this throughout cycle, like from here to here, initially the payment status is pending. Now what will happen is when the payment is when our user puts an OTP. Now that is again a buyer interaction, but our system will not come. So what the buyer used to do is, in the PSP, in the PSP's platform, they are going to place their OTP there. Okay, OTP or any other kind of verification. So once this verification passes, that is known as 3DS pass. When this 3DS pass happens, our payment service provider will emit an event. Okay, our payment service provider will emit an event, pass event, and that pass event, our payment service or our platform service, they need to listen to. Okay, so once this 3DS pass happens, like if I just draw this part, okay, once this 3DS pass happens, once this event goes there, our system will mark the status from pending to passed. Okay, now how this thing will happen, how my system is going to listen to this event. So it is going to create a WebSocket connection, a WebSocket connection with a timeout of 2 minutes. So once a WebSocket connection is created, WebSocket is like if I have to uh, tell you more generic example, when you are talking to your friends over WhatsApp, what exactly happened? There is a WebSocket connection that like you are connected to a WebSocket server, both of your friends and your WhatsApp client is connected to that, and there is a two-way communication happens between these two um, these two clients. Okay, so similar kind of a thing, because WebSocket connection is a little expensive one. So what will happen is it will keep on listening to the this connection for 2 minutes. If in 2 minutes nothing happens, then by default it will just close the connection and mark the payment status as failed. Okay, mark the payment status is failed in case the WebSocket failure happens, or even the payment status failure we get. So while handling the payment delay, getting into a WebSocket or even SSE like server sent events, having it in that way is very much required. Or even you can design your own webhook, which you will keep on polling in every 2-3 seconds for next 2 minutes. But yeah, WebSocket is one of the tried and tested mechanism in this kind of process, that while handling payment delays, I create a WebSocket from my client to the PSP server, and it will keep on listening to for a given stipulated time period. Okay, now after this, if you see all the system that we have been designing so far, okay, one of the big uh, flaw of the system we are designing so far is this system is kind of monolithic. So if you see over here, if I am having a payment API and having like um, uh, 10 servers over here, because a organization with a scale of a Shopify or Amazon, they will not be able to handle all of their payment services in a single server, right? So which server my buyer will connect to and how the rest of the things will come together, that is very important. So let's talk about what was missing in our approach. Okay, so this, just understand this thing very deeply, that a scaled payment service is not at all a monolith. Okay, so we have different parts like incoming, payments, we have processing, payout, update, ledger, fraud check, reconciliation. Okay, all these things are separate services if you see. So how we are going to handle this whole service? Basically, what our system is going to have is, our system is going to have a totally event driven approach, or like the S2S or service to service connections using gRPC or REST. But generally, like in this case, event driven approach will shine. Why? Let me talk about that. Suppose there is a payment request comes. Okay, there is a payment request comes, and what I'm going to do is I'm going to place it on my Kafka or in my message queue. Okay, so from that message queue, what will happen is there will be payment order created, event will be, one event will be published. Okay, so let me just draw these two things because these are system and this is my event. Okay, this event will be published. So what it will happen is it will then run on to the risk check service or the fraud service. In one way it will go, another thing will go, might go to the analytical service. Okay, analytical analytical service. Another thing will go as a notification service, like to trigger email sort of a thing that okay, we have started creating your order or sending user a push notification. So there can be multitude of use cases around that. So I'm going to have a payment order created event and all these things will be happening, and one definitely will go to my main PSP. Okay, so that PSP PSP will be like, there is going to be some kind of a service in between which is going to pass this thing into our PSP. Okay, and then when our PSP comes back, again I'm going to place my payment processing thing into Kafka, and from there again it will go into the analytical, it will go into the notification, and it will go into my systems like my database as well. Okay, so if I place database here, Kafka payment service, and from here also I'm going to pass it to the database. Okay, so this is what a event driven approach would look like, because whenever a payment order is getting created, there are multiple side of our system, like our analysis, like our analyst might be required that for a certain region how many order are getting created and how many are getting failed over time. So all those details to capture, we are going to need a event based approach over here. Okay, so like this is never going to be a monolith sort of a thing, or even like a single S2S service to service connection. Mostly it is going to be a Saga based connection, that I am going to publish my events to different to a given queue, or a service like Kafka, and I will have all my services listening to that particular database. Okay, so as you know, like this pattern is known as like Saga pattern. Okay, so we are going to have a like a event driven Saga pattern for this, and I hope it is clear why event driven Saga pattern will be the most useful here. Just to reiterate, if I am just doing a simple S2S, I again and again have to establish relationship between two services. Okay, and that can be like binding their contract and binding how those data are to be transferred, and the success failure message, everything, it is going to be a hassle. So instead of that, we are going to have a event driven architecture on this, event driven saga model on this. Okay, so this is what one of the most again important part of the system. And then two more thing that we need to cover over here. One is like basically the handling the payment failures. So what happens for a payment failure? Okay, so payment can fail for different reasons, right? Like expired card, insufficient funds. It can be even something as trivial as my network didn't work correctly. Okay, so robust system will not generally give up on that in a single attempt. So any kind of failure that happens, okay, in this whole process, any kind of failure that happens, we are going to have our own retrial mechanism. And as you saw that if there will be a circuit breaker and the idempotency will be there. So in case a failure happens, I'm going to just add one more thing here. In case a failure happens, we are going to log the failure in something called dead letter queue. Okay, so because we are doing a event driven architecture, so understanding of the dead letter queue is little bit important. Suppose I am exposing one events for one payment event I have generated. Okay, so this payment event will go to my Kafka, and after this Kafka, if I don't get a success of that particular, if I'm unable to process that request, what I'm going to do is I'm going to retry it for a given, maybe like a stipulated time, maybe 5 times. Once, if it fails for all the 5 times, okay, on failure, all the 5 times, I'm going to flag this particular transaction into my dead letter queue. Okay, and why this dead letter queue is important? So it is very important for the analytical teams. What they will generally do is they will come back to the system and they will try to see things like why a certain payment event got failed. Okay, so that's why in handling payment failure with this retry and the circuit breaker, so once that circuit is being break, so on failure or on circuit break, I will move it to the my dead letter queue. Okay, so this is one of the important aspect that I wanted to touch upon. And now let's come on to our last but very important thing, that is exactly once delivery. Okay, or idempotency. So what is the definition of it? Like if there is a certain API I have, if there is a given endpoint with same idempotency key, it should always give me same result. So what is the implication of it? Suppose I have a post request, okay, and that post request in some way creating some data in my database. Now suppose I fired a same insert into sort of a statement two times same insert into. What will our API, a good idempotent API, will do is it will tell that yeah, it is success or already exist. Okay, so it will not create any duplicacy. So same here, um, especially while taking things from a message queue I am retrying, it is possible for a message or a request to be delivered or processed more than once. Exactly once delivery and this exactly once processing, I would say, ensures that even if a message is delivered multiple times, okay, effect on the system is same. So the code is, even if a message delivered or consumed by the same consumer multiple times, I am going to have same result. Okay, I am going to have same processing result. So, for example, Stripe's idempotency queue mechanism is a very popular one, and it asks the user to create their idempotency key in a certain way, like taking your order ID, taking your some other details regarding the user details. It creates a kind of a hash key which is being used as an idempotency key, and this idempotency key is core for maintaining the idempotency key is the code for maintaining the exactly once mechanism, maintaining this mechanism. Okay, so what happens is this idempotency key I am going to pass with my HTTP request header, and when my API has to be equipped in a way that if I am getting that same idempotency key again and again, it will tell key this is already being processed or this is already in progress. In some other way it will respond. Okay, so as I was telling, like Stripe idempotency key mechanism allows you to send the same key with the retry, and if Stripe sees that the key was already processed successfully for the account, it simply return the original successful result, okay, instead of processing that charge again. So I think we have covered a great ground so far. Like we tried to understand how a payment service, how a seller buyer, the payout, pay in, everything comes in together, and how PSPs makes this whole system possible. What is the importance of reconciliation? And then gradually from there, we moved into the importance of the event driven system, and we also discussed couple of nuances like how we can make, what are the events that we can publish, and how we can make our system very distributive in that manner. And then we discussed couple of more things like handling the payment failures, and then we went on discussing in detail about the idempotency key. So that's the video, guys. I hope you got some good idea around the Amazon payment process or any big conglomeration conglomerations payment processing system. And in the next video I will try to cover some kind of a digital wallet or like this Stripe or Paytm, how they work internally. That will give you further insights into this kind of payment processing system. So till then, I wish you all the very best, and thank you for watching this video. Please post any questions that you have in the comments. I will try to answer it as soon as possible. Thanks a lot once again. Take care.